Right. So this next talk is by me, Sebastian Strollo, and Amy Simonson. You'll know us as the two tall Scandinavians up here. So hopefully you'll remember us and stop by our booth later. But today, so I have this little thing that I have a suspicion that many of you have been told that Kubernetes is what you should be running for your edge applications. And why wouldn't you believe that? I mean, it's a de facto standard in the cloud, and it runs on the cloud, so why not on the edge? But if you've tried, I'm also willing to bet that you had a problem with getting all the way. You started with high hopes, and you know this. It's Kubernetes. It's easy enough. And then you find yourself weeks behind schedule and over budget, application teams starting to say, hey, when can we actually run our applications? So this sound familiar? We're going to have a little story for you. So we'll show you why we think that you should leave Kubernetes where it belongs, in the cloud, and embrace a purpose-built solution instead that actually works on the edge. But let's take a step back and understand what we're dealing with. So just a quick word about Avassa and why we're here. A Swedish software company. We provide a platform for managing and operating applications that are based on containers at the edge. And when I say the edge, I mean a lot of people have different ideas of what that could be, but we mean the on-site edge. Real locations where your applications need to run, so whether that's industrial facilities, retail stores, or anywhere else your business actually operates. So we have a horizontal solution, and we have customers in all kinds of verticals. So today I'll guide you a bit of what, and show you a little bit what we've learned about moving away from trying to force Kubernetes into edge scenarios and embracing a purpose-built alternative that actually works in resource-constrained and distributed environments. So let's get started. So where did this beast come from? Well, it started at Google back in 2014. They released this open source version of their internal Borg system. And what we want to remember from that, the takeaway is that they actually designed this to orchestrate container applications across compute clusters with automated scaling and deployment and recovery. So perfect if you're building a web application where you need to scale out during peak traffic or data processing, or where you can spin up more containers just on demand. So these core design principles, they're brilliant for their intended use case. Abstract away hardware. You don't think about hardware anymore. You can just focus on the application. And it really shaped how we do applications today. I mean, we broke down our apps into microservices, and we made them stateless, and we worked really hard to get there the whole way. And so where does that actually really work really well? In environments with elastic resources and homogeneous infrastructure, i.e. the cloud. But we use the term Kubernetes, but we really just mean Kubernetes itself. We typically talk about a whole slew of things. I mean, I think you've all seen versions of this picture. I mean, if you Google the CNCF landscape, you'll get an even more detailed version than this. So there's a lot of tools out there to pick them from. So when you actually want to run your application, you're going to need members from this whole village. I mean, you're going to need monitoring for both your clusters and the applications themselves. You're going to need service meshes. You're going to need log collectors, security scanning, ingress controllers, storage solutions, and so on and so on. I bet there's vendors here selling you a plugin to do one or two of those, or you're using one of the open source ones. I mean, I think the abundance of these is both a blessing and a bit of a curse. On one hand, there's incredible tools available for anything you need to do. But on the other hand, there's just so many tools to choose from. So do you go with Prometheus or Datadog for monitoring? Istio, Linkerd, Service Mesh, Honestly, I don't know about you, but I have a little bit of a hard time keeping up with what the latest ITS tool is these days. But fortunately, in today's cloud world, most organizations consume these as managed services. You're not really trying to get all of these to run yourself. You're basically picking and choosing from a menu from your favorite cloud provider. So be that you're running it in GKE, AKS, or EKS, or whatever the KS combination is the fat of the day. And that's a good thing, right? You don't have to worry about getting all these configured right. But a little bit of a trap here that I've noticed is that a lot of, even when you're using these managed services, infrastructure teams can get very caught up in just getting the perfect setup and just right. And they sometimes lose sight of the goal itself, getting applications running and delivering business value. We'll talk a little bit more about that later. So, in conclusion, the ecosystem approach works really well in the cloud, especially when you get it as a managed service. But when we take this complexity all the way out to the edge at many, many locations, it creates a fundamental problem. So even with these underlying differences, how can we use the application paradigm that we like? We want to keep these containerized applications. We learn how to write apps in a small and sometimes stateless and sometimes just scalable way. So let's understand what's different about the edge from the cloud itself. So location. When you are in the cloud, you don't really care about location. You may, at the most, pick a region, depending on latency or compliance. But at the edge, location is the whole point. You're running that application at a specific factory because it needs to be physically connected to the manufacturing equipment. Or you're at that retail location because you need retail customer analytics. So location isn't abstract anymore, it's the entire reason that you're actually there. Physical security. At the cloud data center, I bet most of us haven't even been in one. They are controlled access, security guards, biometric scanners, but the edge devices, you might be sitting in a retail back room, mounted on a factory wall, or anywhere where just anyone with a screwdriver can access this and even actually physically steal it and walk away with it. Resources. The cloud have a very nice abstraction. When you need more compute, you pretty much have infinite elasticity. Just scale up, push of a button, and opening your wallet. And at the edge, you have a fixed hardware budget, period. You might have a single industrial PC at 8 gigs of RAM, and that's it. If you're lucky, you might have a cluster of a couple of these just for redundancy, but you can't throw more resources to solve a problem that you have. At the cloud data center, you typically have multiple fibers for redundancy. They have 99 with they probably have 5 nines uptime, but your edge location might have a single internet connection that goes down when someone hits a telephone pole or when bandwidth gets throttled during peak hours. And the hardware is typically homogeneous. So in the cloud, you just run the same thing. The VM is the same. You just spin up one more. But at the edge site, you might have one site with Intel or AMD, and you might have one site with just ARM chips, and the third site just has some weird legacy hardware that you're not allowed to replace just yet. So when we try to take our cloud tooling and just drop it at the edge, we're essentially trying to force a square peg into a round hole. The constraints are completely different. And that's why we need to think a little bit differently about our approach. But let's take a bit closer look at the players involved. I think Amy will give us an introduction to who this concerns.
I will, thank you. So to help us look closer at the behavior of Kubernetes at the edge, I would like to introduce you to our team. We have created these two protagonists because we come across them quite a lot when we talk to our customers and users. So on the right-hand side, we have Patrick McEngine. He is an IT or platform engineer. And Patrick is typically in an organization responsible for planning and designing and actually configuring the infrastructure stack. He selects hardware, he picks an operating system or a Linux distribution, and he is very passionate about that. He is passionate about the infrastructure layer. But not only that, he is also an enabler. He is an enabler for application teams. And that brings us to Applifer Developers. She is our Edge application developer. That means that she is responsible for planning and designing and actually often building and coding the applications themselves. Applifer is usually, let's just say, less passionate about infrastructure. She doesn't really care. She builds applications and she cares about the purpose and the functionality of the actual applications themselves. And it's usually the work of Applifer that drives the value stream in an organization. So if you're a small organization or a very well-oiled machinery, these two protagonists is of course sometimes the very same person or the same team. But we often come across organizations where that's simply not true. These are two different parts of the organization, but they are forced to collaborate quite a lot. Applifer and Platrix out there, they have different objectives and different way of working, but they are equally challenged by the fact that the edge actually is very different from the cloud that Sebastian just told us. And that tends to become quite a lot of hassle for them when they attempt to use the tooling that they know and love from the cloud, also for the distributed environments. So just like in the cloud, Applifers and Platrix, they select a set of services for lifecycle managing their applications at the edge. And again, to Sebastian's point, when we say Kubernetes, let's just say they pick Kubernetes for managing those applications, it's very often so that we don't mean only Kubernetes. We mean a whole set of surrounding services. We need to pick something for securing the data. We need an observability tooling. We need something for deployment, monitoring, and of course, installation of new sites and applications. So when taking this set of services to the edge, it becomes a little bit of a challenge for both Platric and for Applifer, because they need to run all of these services in each and every location where they want applications running and operating. So let's look at a typical day in life for our team here. Applifer, as the driver of the value stream, again, she develops the applications. When she reaches a point in time when she is ready to deploy, she typically turns to Platric because she expects him to keep track of the edge environment, which infrastructure is placed where, and how she should go about actually getting her application out to where it needs to run. So a lot of times we talk to customers that when reaching that point in time where they're ready for deployment, it's a quite manual handover and 6 or 7 meetings of looking at Excel sheets to try to figure out where this application actually can run. So Platric, he has this set of services that he needs to replicate in each and every location where this application needs to run. And that's not a problem if it's 1 or 2 data centers, but it tends to become a little bit complex if it's hundreds or thousands of locations, because he needs to replicate those services everywhere. And to build on top of that complexity, Applifer, she prioritizes feature velocity and innovation. So she will continue to come with her deployments time and time again. And this creates a lot of hassle. And not only that, Platric might need to cater to the needs of not one team of Applifers, but several. So he requires some sort of multi-tenancy support to be able to share infrastructure among 1, several, or even third-party application teams. So this is going to be challenging for them. If using Kubernetes and a whole set of surrounding services, it's going to be slow. Platric, he's going to spend most of his time actually just maintaining the infrastructure, and it's going to consume way more time from him than would actually be needed. He needs to upgrade the infrastructure, he needs to secure it and maintain it over time. when Applifer, well, she just really wants to deploy her applications. Again, she is not very passionate about infrastructure, and this, in many organizations that we talk to, create a little bit of a, not conflict, but let's just say sometimes frustrating meetings in between these two parts of the organization. So, what expectations should we then have on the tooling that we use for the on-site edge? And how is that tooling different from the tooling that Applifer and Platric use in the cloud? Sebastian, help us sort this out.
All right, let's see if we can make both Platric and Applifer successful, and keeping the application containerized and focus at the business value, just like they wanted. So, what does that mean for the tooling? So here's a list of characteristics that we looked at before, and let's go through them and see what they actually demand from an edge platform. So we talked about the geographic location, and I said that it was really the whole point when you were working at the edge. So that means you need a targeted deployment model. You can't just say deploy everywhere. You need to deploy specific applications to specific locations based on what's actually at that location. So your AI inference model goes to the sites with the cameras, and the inventory management goes to the warehouse. Your customer analytics goes to retail locations, and your platform needs to understand this geographic targeting, not treat it as an afterthought. And the absence of this physical security really means that you must have a zero-trust, edge-native security. You can't rely on perimeter security, because as we saw, there isn't one. Every device must assume that it can be compromised. So tamper detection, encryption at rest, encryption also in transit is required. You need a secure boot process, tamper detection, and the ability to revoke and rotate credentials and certificates remotely. So you can't really bolt this on. You really need to have it baked into the DNA of your edge platform. When it comes to resources, since at the edge we concluded that they are limited, so you must actually have basically what it means that every megabyte of RAM that your platform is using, that means your application can't be using that. So if your platform just needs 4 gigs just to start up, well, in our example, that means you already lost half the hardware budget on a typical edge device. So your platform needs to be lean and efficient, not bloated with features you don't need at the edge. So how do we handle the intermittent or limited connectivity? Well, it means that you absolutely must have offline capabilities and autonomy. When that internet connection goes down, and it will, your applications can't just stop working. Your platform needs to continue operating, making local decisions, healing itself, restarting applications as they crash, and queuing up changes for when the connectivity returns. So when we have the mix of hardware environments that demands hardware adaptive orchestration. So your platform can't assume that everything runs on the same processor architecture or the same capabilities. It needs to understand that this application can only run on Intel, that one needs a GPU, and this other one requires some specific hardware interfaces. So this list is not just nice to have, they're fundamental requirements that determine whether your edge deployment succeeds or become a maintenance nightmare. So, let me ask you a direct question about Kubernetes. I think this is the reality check we all need to hear. So, take a minute and think about your own target environment. Is it highly distributed across multiple locations? Is it physically unprotected, sitting in the back of a retail store or at multiple factory floors? Does it have spotty connections that go down regularly? Are you working with very limited compute resources? I see some of you nodding at least. Maybe thinking about your own distributed industrial PCs or NUCs or edge servers scattered across the locations you have. I think the truth is that Kubernetes will give you a headache in this context. You'll spend more time fighting the platform than delivering business value to your organization. In fact, maybe you already are. But, and this is important, if your target environment is highly centralized in a nice data center, secured with proper access controls, reliable bandwidth connectivity, and you have unlimited resources to throw at problems, then Kubernetes is absolutely a great choice. It's brilliant for that use case. So the problem isn't that Kubernetes is bad. Kubernetes is fantastic for what it was designed for. The problem problem here is that we're trying to use a cloud-native solution to solve edge-native problems. So it's like trying to use a Formula One race car to haul furniture. Wrong tool for the job. Or it's like trying to use a full orchestra to play background music in the coffee shop. Massively over-engineered for the environment. You get the point. The fundamental mismatch is what's causing the pain. So, how do you make the right choice for your specific situation? I brought a little checklist here from so hopefully that can help you from making expensive mistakes. So this is a long one. I'm not going to read it, but please, and you already are, take a picture or reach out to me and I'll definitely share it with you. It's basically it's some of the lessons that we've learned over time. Okay, so what's the conclusion? We covered a lot of ground here, and here's what really matters. First, Kubernetes was built for the cloud, not the edge. It shines in centralized, resource-rich data centers, but it breaks down in the offline, resource-constrained realities of edge environments. Trying to retrofit it will cost you months of delays, budget overruns, and frankly, your sanity. Second, the edge demands a purpose-built approach with appropriate abstractions. True edge solutions must support small footprints, offline survivability, application-centric management. They need to deliver seamless operations even when connectivity or compute is limited. This isn't just theoretical. These are practical requirements we've seen organizations struggle with again and again. Don't forget to focus on value, not infrastructure hassles. Every day you spend wrestling the infrastructure is a day your competitors are delivering real applications that can create business impact. So leave that complexity behind, pick tools that abstract away infrastructure pain, and let your teams focus on what actually matters. Deploying, securing, and scaling applications where they create real-world value. At the edge, there's a lot to keep in mind, and with the right tooling in place, it gets a whole lot easier. Incidentally, a lot of these are lessons we learned and took with us as requirements when we designed the Avassa Edge platform. So I'm going to hand over to Amy now and show you a little bit what we did to address some of these requirements and how it can change the way your teams work.
Yeah, and I know we're running over time, so I'm going to keep this short as possible. It's the speedy version, and fortunately we're exhibiting here, so please stop by our booth if you want to talk to us more about this. But surprise to no one, we have actually built a purpose-built tooling for managing applications in edge environments where at times connectivity is down and where resources are very constrained. We can meet this checklist that Sebastian told you about earlier, and we address the use case of extending application workloads from the cloud to the edge with tooling that is actually purpose-built for precisely that. So please stop by our booth if you have any more questions for us, because I know we ran straight over our question time. So thank you very much for listening.